Hi guys, and welcome back to my channel. This is episode 13 and the final one of the Glaciated Landscapes and Change series over here on my channel. I hope you've learnt something throughout this series. Today we're going to be looking at tundra ecosystems and I hope it's useful. Next week will be a slightly different video. It will be how to get an A star in A-level geography. How to get an A in A-level geography. I hope it'll be useful for you because that's what I got. So I just want to talk through my revision techniques with you, and I think that'll be really useful, and I thought it was a good time to do it as like the break in between two topics, and then we're going to move straight on to globalization. So yes, please do like, subscribe down below if you would like to see that, and let's just get straight on into this video. We might as well get it done right now. So let's go. A fragile ecosystem. It's said that if you tread on tundra vegetation, your footprint may be visible for a decade. Tundra, found in glacial and periglacial environments, is unique and fragile, one of the Earth's coldest and harshest ecosystems. Tundra ecosystems are surprisingly diverse, but they also develop very slowly. Tundra plants and animals have adapted to the harsh climate and a short growing season. But they are very sensitive to change. Once damaged, they may never recover. They are highly vulnerable to environmental stresses, such as reduced snow cover and warmer temperatures caused by global warming. Arctic tundra. The Arctic is a harsh environment with long, dark winters and short summers. The growing season only lasts for about 3 months, when average temperatures rise to about 12 degrees centigrade a year. At this time, the surface layer of permafrost melts to form bogs and shallow lakes. These attract insects, which in turn attract migrating birds. The Arctic tundra ecosystem also supports a large variety of larger animals, including Arctic foxes, grey wolves, snow geese, and musk oxen. In winter, temperatures fall well below freezing. Plants, which many animals rely on for food, must survive under snow to re-emerge and flower quickly once temperatures rise again in the spring. How global warming is changing the Arctic tundra. Rapid warming of the Arctic has contributed to more extensive melting of sea ice in the summer months, as well as greatly reduced snow cover and a reduction in the permafrost. Shrubs and trees that previously could not survive in the tundra environment have now started to grow there. The same is true of animals. In Alaska, the red fox has started to spread northwards and is now competing with the Arctic fox for food and territory. The Arctic region is now warming twice as fast as the global average. This phenomenon is known as Arctic amplification. What is Arctic amplification? The Arctic acts like a fridge, giving off more heat than it absorbs. Scientists are concerned that this process may be affected by 3 positive feedback loops, which I'll explain in a minute, which are expected to worsen as the climate changes. Number 1. As the extent of white sea ice reduces, a smaller fraction of the sun's radiation is reflected back into space. More solar energy is then absorbed by the darker, ice-free water, raising temperatures that further reduce global ice cover. Number 2. When permafrost melts, it releases trapped carbon into the atmosphere as carbon dioxide and methane, thus increasing concentrations of greenhouse gases in the atmosphere. This in turn leads to increased global temperatures and further melting. Number 3. Lower levels of snow cover increases areas of bare rock exposed to solar energy. Heat absorption from the sun then increases, leading to increased temperatures and snowmelt. Together, these 3 feedback loops exacerbate global warming, hence the term Arctic amplification. Changes in the carbon cycle. As much as 14% of the Earth's carbon is stored as permafrost, accumulating because the cold limits decomposition of organic matter. However, not all agree that melting permafrost will release stored carbon as CO2 or CH4. Some studies show that as permafrost thaws, stored carbon actually remains in the soil to be used by new vegetation. Although warmer temperatures accelerate decomposition, releasing carbon, they also increase the release of nutrients. Nutrients encourage plant growth and the removal of carbon from the atmosphere through photosynthesis, decreasing the level of greenhouse gases in the atmosphere. Increased plant growth is therefore a negative feedback opposing Arctic amplification. Scientists at Alaska's Arctic Long-Term Ecological Research Site set up artificial warming plots over 20 years and found increased growth of shrubs at the expense of mosses, sedges and grasses. Measurements show no sign of change in the amount of carbon below ground, which means that carbon release due to melting permafrost has been balanced by carbon input into the soil as a result of more plant growth, the decomposition of plant litter. However, scientists are cautious about what this might mean for the future for two reasons. Number one, the effects observed may be transitional and further warming could lead to major release of carbon. And number two, although carbon is still being stored on land, the opposite is true of lakes, streams and bogs, where more carbon is released than stored. Alpine Tundra. The vegetation in mountain or alpine tundra consists of grasses and low-lying plants. Hardy cushion plants survive by growing in rock depressions, where it's warmer and they are sheltered from the wind. In the warmer summer months, wildflowers attract insects and birds. This biome is also home to mountain goats and sheep, as well as marmots, which are large burrowing rodents. Climate change in alpine ecosystems. Alpine ecosystems are predicted to experience significant change as the climate warms. A rise in temperatures of 1 degree pushes the tree line 100 metres higher. Other vegetation is pushed higher too, and some high mountain flora and fauna may become extinct. In the Swiss Alps, other possible impacts include continually retreating glaciers because significant melting now occurs in the summer months. This may threaten glacial outburst floods, causing dangerous flooding and mudslides. The possible closure of ski resorts at lower altitudes, as research suggests that by 2050, only those resorts at 1500 metres and above will be able to offer skiing throughout the winter. Increasing melting of permafrost, which threatens rock avalanches and mudslides. Permafrost covers about 5% of Switzerland. Several mountain settlements are under threat, and so are ski lifts, the supports of which are anchored in permafrost rather than solid rock. Research has estimated that a rise in temperature of 2 degrees will cost Switzerland about £2 billion per year, because of the impact of winter tourism and the measures needed to deal with the increase in flooding and other natural disasters as a result of rising temperatures. Protecting and conserving the Alps. The Alpine Convention is an international treaty, and its members, the EU, and Alpine countries such as Austria, Germany, Italy, France, Liechtenstein, Monaco, Slovenia and Switzerland are all working together to protect the natural environment while promoting its economic development. It's an attempt to work on sustainable development within a legislative framework. The convention covers a range of subjects including water, soil conservation, landscape protection, transport, energy and climate. An uncertain future. Successful management of tundra ecosystems is challenging, and some difficult questions remain that we don't yet know the answers to, such as how much carbon is stored in permafrost, how much will be released into the atmosphere when the permafrost thaws, and how much carbon could be released as CH4 and how much as CO2. If the governments around the world knew the answers to these questions, it could help them decide what to do. There is a clear need for coordinated approaches at a global scale. The 2015 Paris Climate Agreement made little mention of the Arctic or the indigenous peoples living there. And while developed countries pledged funds to help developing nations with climate adaptation and mitigation, similar pledges were not made for Arctic communities. The Alpine Convention. Nature and landscape protection. More than 20% of the Alpine area consists of national parks and protected areas. These areas have a great range of biodiversity. The Alpine Convention includes measures to protect, care for and restore ecosystems, as well as preserve the natural living environments of wild animals and plant species. The Alpine Convention. Water. The Alps are known as the water towers of Europe. Alpine rivers transport an average of 216 kilometres cubed of water a year to nearby regions. In the summer months, much of Europe's water comes from the melting of alpine glaciers. But according to climate scientists, in less than 100 years, the Eastern Alps, as well as large parts of the Western Alps, will be completely ice-free. The hydrological cycle will be affected by this change. Precipitation in the form of snow would diminish and rainfall patterns would change. River discharge patterns would also change, with greater flooding in winter and droughts in the summer. Not only that, but as the climate changes and the glaciers melt, water flows will increase initially, with equivalent increases in sediment yield. As the glacier retreats, however, river discharge would be reduced, together with sediment yield. Water would become increasingly cloudy and sediment laden, decreasing water quality. And that is the end of this topic of glaciated landscapes and change. I hope you learned something, I hope you enjoyed, and then we're going to move on to glaciation. No, we're not. Globalization. So yeah, I hope you enjoy. Please do subscribe down below if you like this series, and share it with someone who you think might find it useful. Yeah, I will see you same time, same place next week. Bye guys.